All right, guys, example 5. You see you're finding area under the curve of this absolute value graph. And let's think about this. Absolute value has 2 lines, all right? And how do you find the vertex? You set the inside, which is, let me use my mouse. Oh, not plugged in, hold on. Which is 2x minus 1. You set that inside equal to 0, and you end up getting the vertex is a half. Okay, so basically if this is 1, this is the vertex, this is what the graph looks like. All right, and we're finding the area under the curve from 0 to 2. So you have 2 different curves. You have this line, let me highlight it. You have this line in red, and you have this line in yellow. Okay, so what that means is, since it splits up halfway in the middle of the interval from 0 to 2, you got to write 2 integrals splitting up at the vertex. So you got to find the vertex first, and you're splitting your integrals up into the integral from 0 to a half, and then the integral from a half to 2 here. All right, and now how do you know which line goes where? Well, if you make a number line, and you put the vertex, which is a half, on the number line, okay? If you test the number to the right of the vertex, say 1, and you put it in here for the x, 2 times 1 is 2, minus 1 is 1. That's positive. All right, so we're looking at a line with positive slope, and visually you can see it here. If you take a number to the left of a half, say 0, and plug it in, your inside becomes negative because 2 times 0 is 0, minus 1 is negative 1. So your inside is negative, so you're looking at the line with negative slope. So from 0 to a half, you are looking at the opposite of this, the negative of this, which would be negative 2x plus 1. And then to the right of a half, you're looking at the positive part of this, which is the exact same thing, which is 2x minus 1. All right, so now we have 2 separate integrals. We're going to do what we just learned, which is integrate it, then plug in the top bound minus the bottom bound. So if I integrate this, I get negative 2x squared over 2 plus x from 0 to a half. The 2's will cancel. Don't forget the negative is still out there. So when I plug in a half, it's negative 1/2 squared plus a half. And then you're subtracting, take 0 and plug it in. Guys, if I take 0 and plug it into both parts, I'm going to get 0. So this is negative 1/4 plus a half, which gives me a quarter for this first integral, okay? Just this part. And that makes sense because in here it looks like it's small area, like a quarter. So now I'm going to change colors just for the sake of distinguishing between the two. Now we're going to integrate this one. So we get 2x squared over 2 minus x from a half to 2. All right, these 2's will cancel. I'm going to take the top bound because that's what the first fundamental theorem says. Take the top bound, plug it in. So you get 2 squared minus 2. Then minus, take the bottom bound and plug it in. So I'm taking a half and plugging in. 1/2 squared, I'm going to write it right now as 1/4, right? 1/2, plug it in here, squared is 1/4 minus a half. So this is going to be 4 minus 2, and then minus what's in here. 1/4 minus a half is negative a quarter. So this is going to be 2 plus a quarter. Now, don't forget, you had this from the first integral too. So the area of the first part's a quarter. The area of the second part is 2 1/4. The total area underneath the curve in here, which is this in pink, the total area is going to be 2.5. Okay, so the main idea behind integrating when you have absolute value is you need to find the vertex. You got to split the integrals up at the vertex. How do you know which is which? Test the number to the right of the vertex, say 1. Plug it in here, makes the inside positive, so you keep it the same. Take a number to the left of a half, say 0, plug it in, it makes the inside negative. You take the opposite of this equation, which is negative 2x plus 1. You integrate each one separately. You plug in the top bound minus the bottom bound, add the two numbers together. All right? Okay. I'm going to move this down. Okay, the average value of a function. This is pretty simple. Average value of a function. So basically, you're finding the average height of a function. So let's say this is my function. F of x. Okay. And let's say from A to B. All right. So this right here would be F of A. And this height over here would be F of B. The average height is somewhere in between, okay? So the average height, somewhere in here, we would say. All right, and that's what you're finding with the average value formula. So you need to know this formula. If you have it memorized, it's pretty easy. 1 over B minus A, the integral from A to B. All right, don't worry about this stuff here. We just want to put this in practice. So first example, find the average value of the function from 1 to 4. You literally plug it into this formula. Here's my A, here's my B. So 1 over B minus A from A to B of 3x squared minus 2x. All right, so kind of ignore this out in front first. So you're going to integrate this. So 3x cubed over 3, using your integration rules, add 1 to the power, divide by the new power, the 3's will cancel, minus 2x squared over 2, the 2's will cancel. You put your brackets from 1 to 4. Remember, you plug in the top bound first, so I plugged 4 in first, that's 4 cubed minus 4 squared, okay? Then you plug in the bottom bound, but you got to subtract that quantity, use parentheses, take 1 and plug it in. Well, 1 cubed is 1, and then you're going to subtract 1 squared, which is 1, so this ends up being 0. So you have 64 minus 16. Don't forget, you're multiplying it by this right here. So don't forget, you're taking this, and you're multiplying that out in front. So that is times 1/3. And this ends up being 48 times 1/3 is 16. So your average height or average y value in this interval is 16. That's what that is saying there. Okay. So that leads us to our ticket to leave, which I would like you to complete right now. Number 2 is an example you can do extra practice on your own. But right now, I want you to do this ticket to leave, which is practicing the last example on the front of this, number 5, with evaluating area under an absolute value curve.